Okay, so for the last part for the techniques of integration, we will be talking about partial fractions. Um, uh, Partial in this section, so we show how to integrate any rational function. So if you remember, rational functions are those functions that has equations with the numerator and a separate equation with the denominator. So it is a ratio of polynomials. So by expressing it as a sum of simpler fractions called partial fractions that we already know how to integrate. So what are these partial fractions? So these are again a rational fraction. However, its numerator is much simpler. No, think 0 degrees for its polynomial or a binomial. In other words, so to illustrate, we have here example. We have 2 all over x minus 1 minus 1 all over x plus 2. And so if we combine these two fractions, um, we combine these two fractions, we can say that it is equivalent to x plus 5 all over x squared plus x minus 2. So in this state, this is a rational fraction, no? However, its its original its original states are from these two partial fractions, in which if you want to integrate this one, it means you will need a lot of effort or a lot of thinking to solve for it. However, if you try to solve this one, if you remember, solving in this way can be, you can use the integration formula of 1 all over u du, which is ln u, right? So you can easily integrate this rather than this. So that's why if we now reverse the x plus 5 all over x squared plus x minus 2, if we reverse that, it will be just equivalent to the basic difference of the two partial fraction, which is 2 all over x minus 1 all over x plus 2. And yeah, in this particular form, we can now integrate this, which is equals to 2 ln absolute value of x minus 1 minus ln of x plus 2 plus c. Or you can say that it is equal to um, ln of x minus 1 squared 2 all over x plus 2 by the property of logarithmic simplification. So yeah, partial fraction is easily can be easily integrate rather than solving it in rational fraction, because you have two equations, numerator and denominator, and we cannot use there is no operation or integration dedicated for that, other than the in differentiation we can use a division rule, but we cannot use that in reverse in the integration. So we need to use the partial fraction. So to see how the method of partial fraction works in general, let's consider a rational fraction. So of course, a rational fraction has an equation, a numerator and the denominator here and here. Let's just say the numerator is p and the denominator is q. In such way, these are polynomials. So it's possible to express the function as a sum of simpler fraction, provided that the degree of p is less than the degree of q, such as rational function is called proper. So what does this statement mean? So we have in fraction, if you recall, we have in simpler form, I know, in simple basic language of terms, we have proper, improper, fractions, no? So, proper fractions if the denominator is greater than the numerator, it is called proper, such as 1/2, 1/3, 1/6. In improper, we have at least greater numerator value, which is 5/2, 7/3, so on and so forth. So in rational fractions, it is also in that way, no? If the degree of your numerator is greater than the denominator, then it is called improper fraction. So if it is less than, so the degree of your numerator is less than the denominator, then it is proper fractions in such way. So we need to also to see that degree so that we could know how to operate or simplify first the equation before applying or separating the rational fraction itself. Okay, so yeah, so if it is improper, then we must take the prevalence step of dividing Q into P by long division. So dividing two equations in that matter such that the n part would satisfy, no? So your SQ would be the quotient, and your R of X, your S of X pala is your quotient, and your R of X all over Q of X will be your remainder. Diba? So in such a way, your S of X is a simpler form, which is somewhat a basic polynomial, while your R of X all over Q of X will be now a proper function. In such a way, you can easily integrate in that way. So in the first example, we have x cubed plus x all over x minus 1. So let's integrate this. So in doing this, we know that the degree of the numerator is greater than the degree of the denominator. So what we will do is we will apply long division. So that would mean it will be equals to x minus 1, or x cubed plus x divided by x minus 1. So yeah, this would see that it will be equal to x squared. So that will be x cubed minus x squared all over, so that would be minus, this becomes positive, so this becomes 0, this becomes plus x squared, then plus x. Next one will be plus x, so this becomes x squared minus x. So this, sakto ba? So x squared minus x. So this becomes minus, this becomes positive. So yeah, so this becomes 0, this becomes 2x. So next one would be 2. So that would be 2x. So that would be 2x minus 2, right? So this becomes minus, it becomes positive, that becomes 0, and now we have a remainder of 2 here. So that would say that the quotient, which is here, is your S of x, and your remainder, which is the R of x. So in combine, this will be your S of x, this will be your R of x, all over your Q of x, which is x minus 1. And we can see that this is a basic polynomial, yeah, that we can easily integrate by using power rule. And this is a simpler form of fraction, which we can use the ln integration formula. So operating this or integrating this would be in this way. So x squared will be x cubed all over 3, x become x squared all over 2. 2 becomes 2x, and 2 all over x minus 1 will be 2 ln x minus 1. Then, of course, the c. So, yeah. So, if in that case, if you see that the degree of the numerator is greater than the denominator, then you have to perform the long division. Before then the end part, you will see a remainder, and that partial fraction will be easier to integrate. So yeah, in the case of an equation 1 whose denominator is more complicated, so the next step is to factor the denominator of q of x as far as possible. So it can be shown that any polynomial q can be factored as a product of linear factors of the form ax plus b, then irreducible quadratic factors of ax squared plus bx plus c, where b squared minus 4ac is less than 0. So, for an instance, we have an equation of x raised to the power 4 minus 16. So, in the first equation, we can see here that your equation is very simple, no? And it's a factor, or is a degree of 1. So, you can say that there is no factor here. Only 1, of course, because it's a monomial is a term. So, because the 2 is a binomial. So, in this case, we have here a higher degree of equation in which we know that this equation has at least 4 or 3 factors. Because if we say it's x over 4, we can say that there are at least 4 factors. So, we know that this equation is equivalent to this, which is x squared minus 4 times x squared plus 4. Yeah. So, this is a perfect square in which we can factor it out to this. So, it means now that you have 3 factors of your denominator, in which you have to take out those factors into some of the partial fractions to make it as equal of the basic equation. So we are trying to transform the rational fraction to be a simpler one. Just like the first equation that we introduced, no, katong kani siya. So kani siya. So kani siya is degree of 2, so we know that there's 2 factor. So we know that these are the factors, and what we want to know is what are their numerators now, in which if we take the difference of this, it will be equal to this expression. Okay. So the third step is to express the proper rational function r of x all over q of x from the equation 1 as a sum of partial fractions. So this will be the equivalent of the partial fractions if we want to find the partial fraction itself. So for this fraction with a degree of 1, we can say it is just a 1 numerical coefficient or 1 arbitrary constant. For degree of 2 or a quadratic equation, we should write ax plus b. So 2 arbitrary constant, and the other constant has a variable of the given x or any variable of the function. So we have many cases of rational fractions, separating the rational fractions into partial fractions, no? So we will tackle all the cases. So the first case would be a product of distinct linear factors. So in which this means we can write that q of x has these linear factors. So monomial polynomials, no, monomial na day. So ang yung mga factors, it means is degree of 1 rata kutob. Wala tay degree of 2. So kung ma-factor out nimo ang equations and the last factors are all linear equations, then this would be the case for you. So the r of x would be all over qx would be equals to the first arbitrary constant a1 all over the first factor, then second arbitrary constant all over the second factor, so on and so forth. Bisag pila pa na ang imuhang arbitrary constant as long as ma-providean nimo tanang factor out sa denominator. So okay, so why not have an equation to be integrated? So in this part, we have to integrate the x squared plus 2x minus 1 all over 2x cubed plus 3x squared minus 2x dx. And investigating this equation, we know that the degree of the numerator is less than the degree of the denominator. So we can say that this expression is a proper fraction, and we will not use the long division method. Rather than we need to factor out the denominator. So first is factor out the denominator. So yeah, so that is 2x cubed plus 3x squared minus 2x. So we have a common variable x here, so we take out the x, which is that is equivalent to x times 2x squared plus 3x minus 2. Now this expression can be factored out. That is x times 2x minus 1 times x plus 2. Now we have 3 factors. So in other words, we have 3 arbitrary constant to be built and to be solved. So therefore your x squared plus 2x minus 1 all over 2x cubed plus 3x squared minus 2x is equals to the first constant, which is x, first factor, plus b for the second constant, which is 2x minus 1, and c for the x plus 2. So we have here a new equation. Let's just say your equation 1. So let's say multiply equation 1 with 2x cubed plus 3x squared minus 2x. Does that mean that you multiply it with the left side and the right hand side? That would mean we will cancel out the denominator in the left hand side. So it will be x squared plus 2x minus 1 is equals to multiplying this first expression, that would be a times 2x minus 1 times x plus 2 plus second expression that would be equal to x times x plus 2 and c times x times 2x minus 1. So here we need to find the a, b, and c, and we need to use the preceding notes in which the numerical coefficient of degree will be equal to the numerical coefficient of this degree. That would rather mean that if we are trying to rearrange this right hand of equation, so that would be let's just say ito lang usahon. Simplifying this one, this would be equals to 2x squared plus 3x minus 2 kani siya b times x squared plus 2x. Here would be c times 2x squared minus x. Rearranging this in terms of x squared, that would be equals to 2a plus b plus 2c x squared. So ang kani og ang kani. So mo na siya 2a 1b na 2c plus the variable of x, which is equivalent to 3a plus 2b minus c times x. Then the constant would be negative 2a. So to make this equal, so of course the numerical coefficient of this is also equivalent to the numerical coefficient of this, and this. So we can form three equations here. So we can write it here. So the first equation would be the variable of x squared, which is 2a plus b plus c, which is equals to 1 for the coefficient of 1 here. Second equation would be 3a plus 2b minus c, which is equivalent to 2. Lastly, 3a plus 2b, sorry. That would be negative 2a, which is equivalent to negative 1. So that would be equation 2, equation 3, equation 4 here. So solving this, we can see that we can solve for RA in the equation 4. So mo na tunahon. That is negative 2a is equals to negative 1. That would say that a would be 1/2. Yeah. For equation 2, that would say that is 2, plug in the value of a, which is 1/2, then plus b plus c is equals to 1. Here we can say that that is 2. That is 2 pala. This is 2. 2a plus b plus 2c. So that is 2c. So it would be b plus 2c is equals to 0. So your b here would be equivalent to negative 2c. And equation 3, okay, so that would be 3 times 1/2 plus 2 times negative 2c minus c is equals to 2. Then you can say in simplification this would be c is equals to negative 110, and you can say your b here is negative 2 times negative 110 would be equals to 15. So you can plug in those three constants now in your equation 1. So let's just say, let's proceed to we don't have space, okay, for a while. Okay, so you can now plug in those values to your equation 1. Okay, so maunsa naman tong equation, so let's rewrite. So the integral of x squared plus 2x minus 1 all over 2x cubed plus 3x squared minus 2x is equivalent to integral of a, which is 1/2, all over x plus 1/5 all over 2x minus 1 plus negative 1/10 all over x plus 2 dx. You can see now that this expression can be easily integrated, and we use the integration formula. Some talking eraser. Integration formula which is the du over u is equals to ln u plus c. So this is equivalent to 1/2 ln x plus, this would be 1/5 times 1/2, that would be 1/10 ln of 2x minus 1 plus negative 10 negative 1/10 ln of x plus 2. And since we are using the c on the partial fraction, so we should use another constant here, which is c sub 1, or we could use k. So it's up to your preference. So just be sure that you could differentiate the variables here. And of course, that is your answer. Okay, so let's proceed. So for this equation, so duha ra tong factors, no? And of course, you just have to, you have only two ano, you have only you have a numerical you have a numerator of a constant here. However, you cannot use the integration formulas here because your degree of your denominator here is higher than 1, so you could not easily integrate this. So write first the denominator. So we know that this is a perfect square, which is a factor of x plus a times x minus a. And then yeah, so we have two factors, so it means you have two arbitrary constant here. So since wala tayo numerator, and we have numerator which is 1, then our denominator, which is x squared minus a squared, which is equivalent to a all over first factor plus the second factor x minus a. Now multiplying all side by x squared minus a, so multiplying both sides by x squared minus a squared. That would be equal to 1 minus a times x minus a plus b times x minus a here. So here, since we have a constant here, we will just use the method of the preceding notes. So it means that the variable of x here, so if we arrange this, so that would be equal to, I don't know, if we use the method that we introduced in the last slide, uh we will get a trivial equation. What is a trivial equation? It means that we could not get value for your two constants, rather you will get just 0. So what we will use is a method of preceding note, in which in first situation we let x as a on your first expression here, and you will set that 1 is equals to a times negative 2a here. So negative a pala. So what will happen, this becomes negative a, so that will become negative 2a. So here your a will become negative 1 over 2a. On the second preceding note, you will let x is equals to a. What will happen, that 1 is equals to b times 2a, so that your b here will become 1 over 2a. So you have here values now. Plugging these values to your equation 1, that would be equal to integral of dx all over x squared minus a squared, which is equals to the integral of 1, negative 1 all over 2a all over x plus a plus 1 over 2a all over x minus a dx. Yeah. So we could take out the numerical coefficient, which is 1 over 2a, and that would be equal to 1 over x minus a minus 1 over x plus a dx. In other words, this is equals to 1 over 2a or times ln times x minus a. Absolute value of x minus a minus ln x plus a, parenthesis, then of course the constant here. So yeah, for the second case, so we have product of linear factors, and that linear factors is somewhat repeated. So nagbalik-balik ang kana na factor. So I've tried this using the first method of the KA. Since all of the factors are kuan man, linear factors na repeated siya, then akong kibuhat is a all over that factor and plus b all over the same factor. Then what I get is not equal to the one that I get from here. So that's why you should also take note of this second case. So if we have a repetitive linear factors here, your second factor or the second arbitrary constant, so ang ubos ana niya would be squared, no? So in this situation, so kani siya, we have x squared dayon times x minus 1 cube. In this situation, katulo ki-repeat ang atong x minus 1. But however, this is a linear factor, then you will not apply the ax plus b. Rather, upon adding a constant here, so kanino, So, ang x pod kikaduha pod ki-repeat. So, a all over x plus b all over x squared. So, x squared na ni siya. For the second constant. For x minus 1, so c all over x minus 1. Second repetition of the factor would be x minus 1 squared. And the third one would be x minus 1 cubed. Notice that your numerator will be just one arbitrary constant also. So let's try that. So of course, let's factor out the denominator here. So our denominator is equivalent to x cubed minus x squared minus x plus 1. This is equivalent to x minus 1 squared times x plus 1. So this is a perfect cube, no? So we have three factors here. Therefore, x raised to the power 4 minus 2x squared plus 4x plus 1 all over x cubed minus x squared minus x plus 1 is equivalent to three partial fractions, which first is a all over x minus 1 plus the second factor, which is equivalent to x minus 1 squared plus c all over x plus 1. So, wala na ang imuhang equivalent partial fraction. So, tulo ha. No. We forget to check the basic step, no? I'm very sorry. So, your degree here is greater than the degree of your denominator. So, which means you have to perform a long division method in which you can get x plus 1 all over 4x all over plus then x cubed minus x squared minus x plus 1. And so, ang kanira na term ato ang i-partial fraction. Ito ni erase na rin. So, 4x. So, multiplying all sides by this equation. So, that would be equivalent to 4x is equals to a times x minus 1 times x plus 1 plus b times x plus 1 plus c times x minus 1 squared. So 4x is equals to a times x squared minus 1 plus b times x plus 1. Nang kaning c would be x squared minus 2x plus 1. So rearranging, so that would be 4x. In terms of x squared, that would be a plus c times x squared plus b minus 2c times x plus negative a plus b plus c for the constants. So we have three equations here. So that would be a plus no b plus c equals to 0. Second equation would be b minus 2c is equals to 4. And the constants would be a plus b plus c is equals to 0. So you have three equations. So here in first equation, man itong first equation di ay. In your second equation, we know that a is equals to negative c. In your third equation, we know that b would be equivalent to 2c plus 4. And for the last equation for the fourth, so that would be a is equivalent to negative c. So negative a would be positive c here plus b, which is 2c plus 4, and plus c, which is equals to 0. Operating this, so combining all the c variable, that is 4c, which is equivalent to -4, and that would mean that your c is -1. Your a here is -1, it's negative c, and your c is -1, so it becomes +1. Your b here is 2c plus 4, so that would be -2 plus 4, that is equal to 2. So you have now 3 constants already. So you can now transform the equation. So let's rewrite. So that is x4 minus 2x squared plus 4x plus 1 all over x cubed minus x squared minus x plus 1 dx. Operating the long division, that is x plus 1, then writing the partial fraction equivalent, that is a, which is 1, all over x minus 1, plus b, which is 2, all over x minus 1 squared, plus negative a, c, which is -1, all over x plus 1 dx. Okay, so this is equivalent to x squared all over 2 plus x plus ln x minus 1 minus by substitution method, so that is equivalent to 2 all over x minus 1 minus ln of x plus 1. Then since we use the constant c, the variable c, so our constant here rather than c would be k. So this is your answer. You can simplify it as x squared all over 2 plus x minus 2 all over x minus 1 plus ln of x minus 1 all over x plus 2 plus k. So let's proceed now with the third case. So the third case contains irreducible quadratic factors, so none of which is repeated. So you cannot factor out the quadratic the equation of the denominator. So ato lang na siyang i-as is. If the degree of that factor is higher than 1, then we will apply binomial factor, no, which is two arbitrary constant and the other constant has a variable of x. And yeah, we will recall this integration formula. We could also use this integration formula in this particular case. So okay, let's proceed. So example 5, we have here denominator is equivalent to 4x cubed plus 4x. This equation has factors of x times x squared plus 4. Now you cannot factor out this factor, so you can just leave it. So it means that your 2x squared minus x plus 4 all over x cubed plus 4x, which is equivalent to a all over x plus bx plus c all over x squared plus 4. Okay, multiplying all sides by x cubed plus 4x, so we can get 2x squared minus x plus 4 plus, a times x squared plus 4 plus bx plus c times x. Simplifying, so we will get a plus b times x squared plus cx plus 4a. So you have three equations again. I know two equations there. So first is a lagi. Three equations lagi. So first is a plus b is equals to 2. Second would be c is equals to negative 1. Third is 4a, which is equivalent to 4. And this would say that c is equals to negative 1. Your a here would be equals to 1 also. It means that here this becomes 1 plus b is equals to 2, then b is equals to 1. Now plugging it here or directly here, this will be equivalent to integral of a, which is 1, that is 1 over x, plus bx plus c, which is x plus or x minus 1. X squared plus 4 dx. So the other reason why we use two arbitrary constant with a variable of x, or a binomial expression for a second degree factor, is that when you use substitution method, you can apply the integration formulas of ln, since your denominator has a degree of 2 and your upper or your numerator has a degree of 1, so you can now apply the substitution method here. So yeah, taking out this, separating all the integration, the partial fractions, that would be mean dx, integral of 1 over x dx, integral of x all over x squared plus 4 dx, minus integral of 1 x squared plus 4 dx. Now we could use some trigonometric integration formulas here. So here, that is ln of x plus 1/2 of ln x squared plus 4 minus 1/2 of arctangent x all over 2 plus k. Okay, we are down to the 6th example. So in this equation, we have equivalent of two equivalent degrees of numerator and denominator, in which case we can also use partial fractions in this situation, but I think it would be better if we use long division method here first before taking out the partial equation. But yeah, I think the partial equation here would not be applied. So lang ta. So long division would be solving in this in 1 plus x minus 1 all over 4x squared minus 4x plus 3 dx. Now your 4x here plus 4x plus 3, which is equivalent of a factor of 2x minus 1 squared plus 2. So notice that this is somewhat similar to the numerator, so we can use substitution method. So we let u as 2x minus 1, du as 2 dx, x as, of course, that is 1/2 times u plus 1. Yeah, substituting those or plugging those values, that would be equivalent to integral of 1 plus x minus 1, which is 1/2 times u plus 1 minus 1 all over 4x squared minus 4x, which is equivalent to 2x minus 1 squared plus 2, which is equivalent to u squared plus 2. So you could say that it is u squared plus 2 here. Then your dx is 2 dx. So you can now separate the integration so that the integral of dx, multiplying this, so this becomes 1 and this becomes 2, meaning 1/2 times u plus 1 minus 1 is equivalent to u plus 1 minus 2, which is equivalent to u minus 1, diba? So this would be equivalent to integral of u minus 1 all over u squared plus 2 dx. So this will be equivalent to x for the integral of dx, and yeah, separating this, so that would be integral of u all over u squared plus 2 minus integral of, so this would be, no, that's why I'm hesitating. So your du here should, your dx here should be equivalent to du over 2. So instead, ito ni-erase. So I finish up. So your dx here is equivalent to du over 2. So this would means that this will be 1/2 times 1/2 of u plus 1/2 minus 1. Now if you take out wait. So yeah, so if you simplify this, this would be equivalent to integral of 1/4 times u minus 1. So multiplying that is 1/4 minus 1/4 all over u squared plus 2 du. No. So that would be equivalent to 1/4 of u plus 1 minus 1/2 all over u squared plus 2 du. Kani pod na kani siya para ma-separate ni nato daan diri. So kani siya diri would be integral of dx. This would be a separate integration because we did not apply substitution here in the very beginning. So that would mean this will be equivalent to x, and we could take out the 1/4 here, which is equivalent to the two terms, which is equivalent to plus 1/4 of u plus 1 or over u squared plus 2 du minus integral of 1/2 all over u squared plus 2 du. Ito na ipagawas. It would be equivalent to 1, no? Ba? Yeah. So, kani pwede pa ni na to ma-separate. That would be equal to x plus 1/4 integral of u all over u squared plus 2 du plus 1/4 integral of 1 all over u squared plus 2 du minus 1/2 integral of u squared plus 2 du. Nilapas naman tayo. So that will be, kani siyang duha, pwede na to ma-combine. So kani x plus 1/8 of ln u squared plus 2. Kani siya ma-combine ni nato 1/4 minus 1/2. That would mean negative 2/4. That is negative 1/4. So this is negative 1/4 of integral of this, which is equivalent to times the square root of 1 all over 8 times 1 over the square root of 2 times the arctangent of u all over the square root of 2 plus c. And combine. So, pwede na to i-combine na lang. So, that would be equivalent to 1 over 4 the square root of 2. So, the fourth case is irreducible quadratic factors with repetitive quadratic irreducible, no? So, same as linear factor. So, you will just repeat ax plus b constants. So, pero yung mohang ubos kay exponent of 2 na siya. So, same situation, but it would mean that you will have a more complex partial fractions here. So, yeah. Okay. So, good thing in this example kay iyan ang factor out iyang denominator, no? So, we have 3 denominators here. So, it means that we have 3 partial fractions. So, that is 1 minus x plus 2x squared minus x cubed all over x plus x squared plus 1 squared, which is equivalent to a all over x plus bx plus c all over x squared plus 1 for the first factor, and dx plus e for the repetitive factor, which is x squared plus 1 squared. So perform here, we have A, B, C, D, E. So 5 arbitrary constants. And we need to find those. So multiplying all sides in this equation, in this factor, so that is 1 minus x plus 2x squared minus 3x is equals to A times x squared plus 1 squared plus bx plus c times x squared plus 1 plus dx plus e quantity times x. So simplifying, so in terms of factor of 3 na siya. So we have a plus b x to the power 4 plus cx cubed plus 2a plus b x squared plus c plus e x plus a, kanina pa din d. So yeah, first equation would be a plus b is equals to 0. Second would be c equivalent to negative 1. Third would be 2a plus b plus d equals to 2. Fourth, c plus e is equals to negative 1. Last is a is equals to 1. So here we could say that a is equals to negative b, or since na naman tayo b, ay na naman tayo a, ito na in terms of b. So b is negative a, so that would be equals to negative 1. So we have a, b, c. So c would be equal to pila ni? Negative 1 minus, negative 1 plus 1 is siya. So that becomes to 0. No, atong e. Ang e ni siya. Saan to? Ang e. So, kanideri, 2 times 1 plus b na negative 1 plus d na utakay baw is equals to 2. Therefore, imuhang d deri would be equals to 1. Now, plugging those values, so that is 1 minus x plus 2x squared minus x cubed all over x plus x squared plus 1 squared. That is integral of a all over x, which is your a here is 1, plus bx plus c, which is negative x minus 1 x squared plus 1 plus dx plus e. So your e here is 0, then d is 1, so that is just x all over x squared plus 1 squared dx. So integrating this, that is ln x minus 1/2 ln of x squared plus 1 plus tangent. Kani magamit ang tangent formula. So arctangent of negative 1 x minus 1 all over 2x squared minus 1. Positive 1. So, kamo na bahala og simplify ana. So, the last part, we'll be talking about rationalizing substitution. So, this may not be a part of partial fraction, but this is another way for you to solve integration. So, let's just proceed with a problem here. So, here we have a radical equation or algebraic equation here in the numerator. Instead, usually in substitution is we take what is inside the radical symbol, so x plus 4. So what we do here is we take that whole numerator as our u for your substitution. Now your du here would be equals to 1/2 times 1 all over the square root of x plus 4 dx. Of course, your u here is equivalent to, your u squared here is equivalent to x plus 4. And your x here is, of course, u squared minus 4. That would mean here that your dx would be equals to 2u du. Kaya ato naman kilet ang u as square root of x squared plus 4. So, ato na ni siyang himuon og u. So, yeah. Plugging the substitutions terms here, equivalent to x plus 4 square root is u. X is u squared minus 4. Then dx is 2u du. Naman eh. So that is, take out the 2, integral of u squared all over u squared minus 4 du. Okay. So, since we have the same degree of integration, same degree of exponents here, which is 2, we will perform long division, which is, it will be equivalent to 1 plus 4 all over u squared minus 4 du. Here we can easily integrate, that is equivalent to 2, then u plus kani which is equivalent to kanino, kani siya equivalent to 4 na 1 over u squared minus 4. So that will be equivalent to yeah, plus 4 times 1/4 ln of after na lang i-solve uh, in terms of the factors all over kanino katong atong ki ma-apply tong katong atong ki-solve ganina na integration formula, so that will be equivalent to u minus 2 all over u plus 2 plus c, or equivalent to 2u plus 8 all over 4, which is 2 ln u minus 2 u plus 2 plus c. So what you need is, since you have the integration formulas here, katuning kani sa man to kani so pwede ra ni siya magamit as your formula, so that you can easily integrate the last part that we apply it here. Okay, so I think that would be all. Yeah, so we are done with the whole topics for the midterm. So of course, midterm is coming, and I will be announcing the schedule for it. So thank you for listening, and see you on the next one.